Hello and welcome back to another episode of Math with Sohn. Today we're going to be solving logarithmic equations with logs on both sides, which are some of the easiest things to do. Now it doesn't matter if it's a log base 10, log base 3, as long as they're the same, they kind of just cancel out. Whoop, whoop, they're gone. That's it. And then you're just left with 2x plus 4 equals 3x minus 7 in this case. Okay, so once you get to that equation, you solve it like a normal equation. So like I would probably subtract 2x in this case. 4 would equal 1x minus 7. You don't need to write the 1 at all. And then we would add 7. Add 7 to get 11 is equal to x. With log equations, you must plug in the x into both of the logs, or all of the logs for that matter, in any log equation to make sure you don't take the log of a negative number or 0. So if you do that in your head, you're not really checking your solution, you're just verifying that it doesn't make it negative. 2 times 11 plus 4 is like 22 plus 4 is not negative or 0. So that part's good. 3 times 11 minus 7 is 33 minus 7 is also fine, okay? So we've checked both sides, and we move on to the next example. The next one's a little bit harder, but not by much, okay? So let's say we had log base 2 of x squared minus 9 equals log base 2 of 16. Now you are welcome, not required, but welcome to evaluate the log 2 of 16. I think it makes the problem harder because it doesn't matter as long as they are both a log base 2, they cancel out, leaving us with x squared minus 9 is equal to 16. From here, you would add 9, x squared would equal 25, which means when we square root, because you got to square root to get rid of it, don't forget your plus or minus, x would equal a positive and a negative 5. Check both the positive and the negative 5 for x to make sure you're not logging a negative number or 0. And in both cases, 5 squared minus 9 or negative 5 squared minus 9, both of those equal regular 16, so they both work, which is surprising because sometimes the negative ones don't work. Moving right along. So we got log base 4 on this side. By the way, it would not matter if this was log 4 or ln or log 3000. It doesn't matter. As long as they are both the same, they cancel out. So that would leave me with x plus 2 over 3 equals x minus 5. In order to get rid of this 3, we would have to multiply by 3 on both sides. So I would get x plus 2 equals, if I multiply by 3, that cancels that fraction out because currently it's dividing, cancels, equals 3 times x minus 5. Distribute the 3, x plus 2 would equal 3x minus 15. Solve it like you like to solve things, so I would add 15 to both sides probably. I don't know why, but that's what I'm feeling. X plus 17 would equal 3x. Subtract x, get 2x. Divide, x would equal 8.5. So that one, we got the value for x. We need to make sure that when we plug it back in, it doesn't produce a bad answer. Well, if we plug in 8.5, 8.5 plus 2 divided by 3, I don't know what that is, but it is positive, and that's the only requirement. Same thing here. If we plug in 8.5 minus 5, it's positive. So again, it works out. It's not going to not work out very often. That's a double negative, but I don't teach English. Last one, everybody. We got 2 log 3 of x, log 3 of 25. A lot of problems when you have a log on one side, you can divide by 2. Here, if you divide by 2, it will be bad. Don't divide by 2. Instead, make it an exponent on the x. Okay, so this is mostly kind of getting towards the harder problems, which I got a different video for. But in this case, we got x squared when we move it up equals log 3 of 25. Now they're both a single log 3. Now they can cancel out, leaving us with x squared is equal to 25, which we've already solved. We square root both sides, and we get plus or minus 5 when we square root both sides. So once we get that, we would have to plug back our answers. Now the positive 5 would work because 5, log base 3 of 5 is fine. but the negative 5 would not work. So I would like box both of my answers, like x equals this, x equals that, but the negative 5 is an extraneous solution. It does not work, and it would not be included in our solution set. Okay? So that's going to do it for this one. Be continuing to watch these videos because these are just the basic versions. I got a harder version video. That one's probably going to be a little longer because they are harder problems. All right, I will see y'all in the next one. Bye.